Hello everyone, welcome to A plus BI. This channel is all about complex numbers, and in this video we're going to be solving a rational equation with complex numbers. So z is a complex number and we're going to be solving for z. If you're new to complex numbers, go ahead and check out my lecture videos. I made a playlist where you can learn the basics of complex numbers, starting with the definition. What's a complex number? A complex number is something you can write as a plus bi. I is the number whose square equals -1, something that you should never forget, right? So I squared is -1. Some people call I as the square root, but it's not the square root of -1. It's one of the square roots of -1 because -1 has two square roots in the complex world. Anyways, that's a whole different ball game. Let's go ahead and focus on our problem. We have this interesting ratio of two things, or a quotient, whatever you want to call that, and we're going to go ahead and solve this problem in two different ways. All right, so let's go ahead and take a look at the first method first. So to solve this equation, I'm going to cross multiply. So z squared plus 4 is going to equal, if I distribute to z first, 5z minus 10iz, and then distribute to -2i, -10i. Now, if you multiply -2i and -10i, you're going to get positive or plus 20i squared, but that's going to turn into a minus 20 because I squared is -1. Did you forget that? Hopefully not. Now, let's go ahead and put everything on the same side. This is going to turn into a quadratic in z, which we can solve by using the quadratic formula. Awesome. Now, let's go ahead and bring in these two things, but notice that the coefficient of z is going to be on the left-hand side, 10i minus 5, because we have to negate the terms and then just multiply by z. And I'm going to bring this over. 4 plus 20 is 24. So we're going to have 10i plus 24, which you could also switch these around and write it as 24 plus 10i. No big deal. Well, we kind of tend to write things that way because that is the standard form, which is a plus bi. And at the same time, it's the name of this channel, right? That will hopefully help you remember if you ever forget and you need to search for it. Great. So now we're going to try to solve this equation. How can we solve it? Using the quadratic formula, of course. So z equals, and by the way, even if the roots are complex and even if the coefficients are complex, you can still use the quadratic formula. And it's going to have two solutions. -b, which is the negated version, plus minus the square root of b squared. In this case, you're going to square this expression. And then minus 4ac, you're just going to subtract it because a is equal to 1, which is good. And then we're going to go ahead and divide this whole thing by 2a, which is 2. Awesome. Now, let's go ahead and simplify what's inside the radical, and then we're going to place it in there. I don't want to write this everything all the time. If you square 10i minus 5, so in other words, I'm evaluating the discriminant or delta, right? I'm going to square 10i, which is going to give me 100i squared. Let's do it that way first. Plus 25 minus 50, 100i, because I have to double it. Remember the 2ab. And then minus 40i minus 96. Now 100i squared. This is -100 because I squared is -1. And now we have -100 plus 25. Maybe I should do this first. I don't know. -100 plus 25 is -75. And then -75 and -96, we're going to add 96 and 75. That should give us 171, but with the negative sign. So it's going to be -171. And then I have -140i. So here's the challenge. I need to find the square root of this number, and that's not always easy. I mean, it's not too hard either, but that kind of requires either using a formula or just think about where this comes from. The square root of a complex number is actually two complex numbers that are opposites, but I can find the principal square root, which is usually the one with the positive sign, but I can just set it equal to a plus bi. Did I use a plus bi before? No. Okay, let me go ahead and use it then freely. A plus bi, you could also use x plus yi, but a plus bi is better because it's the name of this channel, right? And now let's square both sides. So my goal is to solve for a and b. Remember, a and b have to be real numbers. Let's go ahead and write this first. A squared minus b squared plus 2abi, using the fact that I squared is equal to -1. And I'm just going to set equal to negative 171 minus 140i. And here, by comparing real parts and imaginary parts, we get the following. A squared minus b squared is equal to negative 171. 2ab is negative 140, which means ab is equal to negative 70. Of course, a and b are real. Their sum, product, whatever, is always going to be real, right? So we can solve for a and b. How? There's a couple different ways, one of which is squaring the second equation and then isolating one of the variables. A squared is probably a little easier, and then substituting this right here. So replace a squared with that. So you're going to get b squared times b squared minus 171 equals 4,900 or 4,900. Now, I need to set b squared equal to something like c maybe. This gives us c squared minus 171c minus 4,900 equals 0. And at this point, I need to use the quadratic formula. That's going to be a little challenging, but it's not too hard. By using the quadratic formula, we're going to get negative b plus minus the square root of b squared. That's a big number. Minus 4ac, that's going to give us a plus sign. So here's the challenge. If you can simplify this, you're going to find c, but c is b squared. You have to square root it, so on and so forth. A lot of complications. That's why we have something which is amazing, by the way, something called the second method. Okay, and second method is supposed to be much nicer, right? That's why it's qualifies as the second method. Let's go ahead and talk about it. But if you can complete the first method, I'll appreciate it. I'm too lazy for that, okay? Hopefully you'll help me with that. Now, if I didn't make any mistakes. So here's the thing. When you get a problem like this, let's say you're taking a math test, and it's a math contest or competition or some type of Olympiad, right? Even at the elementary school level, they call them Olympiads. So some people say like, this is not an Olympiad problem. Well, it is. Too bad. I mean, get used to it, right? Anyways, so this type of problem has some tricks. And here's the trick. We have z squared plus 4. If you're thinking complex, you should always think about, okay, sum of two squares can be simplified or factored. How? Well, a squared plus b squared is a plus bi times a minus bi, which is basically the essence of the conjugate of a complex number. If you multiply a complex number by its complex conjugate, you get a real number, which is the absolute value of the number squared. It doesn't matter which one because they both have the same absolute value. They are conjugates. Make sense? So this allows us to actually turn this into a very nice form. So z squared plus 4 can be written as z plus 2i times z minus 2i. Beautiful. Why? Because z minus 2i is going to cancel out. Sorry for my z's. I put a little line through it so it doesn't look like a 2, but at the same time, it probably looks like something else. I don't know. Anyways, that's a z. Bear with me on that. And the whole thing should equal 5 minus 10i. Now, remember the complications that we had with this first method. We don't have those anymore. But one thing to keep in mind, z should not equal 2i, and we kind of need to check it in the original. Well, it doesn't work anyways, so z should not equal 2i. Again, I repeat, z should not equal 2i, okay? Because that's going to cause 0 over 0. Under those conditions, I can go ahead and cancel that out and end up with z plus 2i is equal to 5 minus 10i. And then I can go ahead and subtract 2i and get z equals 5 minus 12i. And that should be the answer. Ta-da, right? That should bring us to the end of this video. But from here, can you kind of figure out what the c value is going to be? Because we know, I think, the a and b values, so on and so forth. And this brings us to the end of this video. Thanks for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care, and bye-bye.